In this video, we're going to take a look at Lesson 4.1, examples 1 and 2, and the warm-up at the beginning. So here we have the model and discuss problem, which has two rectangles here with dimensions 2 by 72 and 6 by 24. So what they want you to do is come up with several different examples of rectangles that would have different dimensions, but the same total area of 144. So we could have one that's 1 by 144. We already have 2 by 72. You could have 3 and 48. We could have 4 and 36. There's a lot of different combinations. We could do 12 by 12. They have 6 and 24 there. And then you could take all of these combinations and flip them around. The dimensions could reverse. You could have 36 and 4 instead of 4 and 36. So what we want to do is take a look and plot all of these on Desmos, which I have done already. And if you've never done this before, you can plot points on Desmos by just putting in the ordered pairs, and then they just show up. There's 12, 12. There's 2, 72, 72, 2. One thing is you would have to zoom out so you can see these. Here's a standard window, and this is me clicking out 3 clicks with the minus button to zoom out. So here are the points, and what shows up is a shape that we haven't really seen before this year, and it is known as a hyperbola. And if we go all the way to the bottom here and put in the equation x times y equals 144, you can see that this is what the function will look like. This black graph here, and as x gets large, y gets smaller, and as x gets small, y gets big. And that concept is known as inverse variation, which is how lesson 4.1 begins, with the concept of inverse variation. So let's see what else we have to look at here. We did A. What happens to the width as the length increases, the width decreases. And how do we describe the relationship between the lengths and the width? They all multiply to make the same constant, 144. And that is inverse variation, which we will look at here in example 1. So how do we determine if a relationship represents inverse variation or not? And here's what we're looking for. When we multiply the two variables, you should always get the same constant, any number except 0. So all you have to do is go down the line here and check 1 times 12, 12, 2 times 6, 3 times 4, 4 times 3, 6 times 2, 12 times 1. So this one is a yes. This is inverse variation because the x and the y always multiply to make 12. But in B, we have 1 times 20 equaling 20, 2 times 17 equaling 34, and that's really all we need to know. If we do not get the same product between these 2 points, then we know that this one is no. This is not inverse variation. All right, so part of your homework this evening will be to check the to go ahead and try 1A and 1B, and you're going to check the products here. You're going to check the products here and see which one is inverse variation and which is not. Now we'll move on to example 2. And in example 2, we're going to use inverse variation. So in these problems, they're telling us that it definitely is inverse variation. And if they tell me that x is 10 and y is 3, first thing we want to do is come up with the k value. So if x is 10 and y is 3, we know that k has to be 30. By the way, you can write out inverse equations 2 ways. you can write x times y equals 30. Or if you're trying to put this in a graphing calculator, you would get y by itself, and you would end up with y equals 30 over x. So throughout this unit, we're going to be looking at functions where the denominator is a variable. And the denominator contains a variable. Let's finish up this. Find the value of y when x equals -6. So for here, we're just going to have to go ahead and put in -6 for x, and we get a y of -5. So for try it 2, you're just going to set up the equation x times y equals k. Use the given x and y to figure out what k must be, and then set up that equation, and then go down to part B and figure out what y would be if x is 15. All right, so that's it. That's your homework for tonight. Do the try it 2A and B, and try it 1A and B, and I'll see you tomorrow.